Welcome. In this video, we're going to look at being given a function and then using that function to state the domain and range. Now, what we want to remember is domain represents the set of possible x values or inputs, and then the range represents the set of possible output or y values. A couple of things to remember. We can find domain algebraically. That means without looking at the graph. But in order to find range, we always need to look at the graph. So before we look at the graph, since we can find domain just by looking at the function, let's determine what the domain is. Remember, we have two questions we ask ourselves before we start a domain problem. Is there a variable in the denominator, or is there a variable under an even root? Now, in this problem, we don't have a denominator, so we know that's not the case. But we do have an even indexed root, the square root of x plus 4. So keep in mind, there's a little invisible 2 right there. Since we have an even indexed root, what we know is that the expression under the radical, that expression x plus 4, must be greater than or equal to 0. So we can say x plus 4 is greater than or equal to 0, or rather, x is greater than or equal to negative 4. So taking that inequality and writing that as the domain in interval notation, that says that since x is greater than or equal to negative 4, we're going to start at negative 4. Greater than means we move right to positive infinity. Since it's equal to, we use a square bracket, and then since you can never touch infinity, we use a parenthesis. So that's what our domain is. And we're going to graph this now in order to determine the range, and we'll see that reflected in what we see on the graph. So when we go to graph this, you want to go to your TI 84, 83, whatever you have. You want to go to your y equals, and you want to type in 3 square root x plus 4, close the parentheses or exit the radical, and then minus 5. So something that looks like this in your y sub 1. Your radical may extend over, it may not. You may open parentheses. It depends on the version of your software. So the older calculators are going to give you these parentheses. And the main point of this is just me reminding you that you need to close the parentheses or exit the radicand before you graph it. And the graph we get a square root graph, which is kind of half of a sideways parabola. It's always going to kind of look like this, depending on these transformations. Again, we get to that later in the semester, but this is what the graph the calculator gives you looks like. So if I ask you to think about the domain, what are the possible x values for this graph? You'll notice we have this point here, this vertex point per se, is at negative 4, negative 5, and that's what you can see on your graphing calculator. You'll see that at negative 4, all the way right to positive infinity, that represents the domain of this graph. So we're never going to have a value that is less than negative 4. All right, well, what's the range? So the range is my lowest y value to my highest y value. Now, it's easy for me to read that on the graph. The one thing I want to make sure you pay attention to is lowest is going to be at the bottom and highest to be at the top. So we're going to go from bottom to top for my range. So reading domain, left to right, that's the way we read. But, you know, in the English language, when we're reading, we read from top to bottom. So you want to make sure that you are stating this range in interval notation from least to greatest. That's going to be the lowest number at the bottom to the highest number. My lowest y value down here is negative 5. So we'll say negative 5 inclusive, and then we will go up to positive infinity. Because even as that graph goes off to the right forever, it's always going up. It's just not going up as fast as it's traveling to the right. All right. So again, just pointing that out, a common mistake I would see a student write here would be to give me that the range, my y values are from infinity to negative 5. Now, if you write that, I know what you mean, but that is not the correct way to write things. So really making sure that we hone in and we write our domain and range in interval notation, least to greatest, left to right. Let's look at another example. For our next example, we're given the function q of x equals -2 times the absolute value of x minus 3 plus 1. All right, so for domain, we ask ourselves the same two questions. Does this function have a variable in the denominator, or does this function have a variable under the even root? And the answer to both of those questions is no. Therefore, that we say we will state that our domain is any x value in the set of all real numbers. So the domain is -infinity to +infinity. What I have boxed here is what you would be typing on the computer or writing on the test. You don't need to write this notation in front. So now let's look at graphing this with our TI calculator. So I want to graph my function. That means I want to plug q of x into my y sub 1, and you can just delete out anything you've previously put in there. So I'm going to type -2. In order to get absolute value, you're going to touch the math button, and then you're going to arrow over 1 unit to where it says number, or NUM. And the first option there says ABS with a parenthesis. So that's how we type absolute value. Now, again, depending on the software, how new or old your calculator is, your calculator may go ahead and draw those absolute value bars. But if it doesn't, then you would have ABS, open parentheses, x minus 3. You need to close the parentheses to close the bars, and then type your +1. So again, if you have older calculator, it may say ABS. A newer calculator might show you those bars. And we find that absolute value by hitting the math button, which is the third button down on the left. So you hit math, and then you arrow over 1 to number. You choose option 1 by hitting the enter ABS. And when we graph that, what we see is a graph that looks roughly like this. When you look at this graph, what you'll notice is that vertex is occurring at +3, +1, and there's a connection there. We talk about transformations later in the semester, but that 3 and 1 in the function are directly connected to this vertex ordered pair being at that 0.31. So as we can see, considering domain, the graph does go to the left and it does go to the right forever. Even though it looks like it's going down, it's expanding to the left and expanding to the right as it goes down. So my horizontal domain, that graph is eventually going to touch every real number from -infinity to +infinity. Now thinking about the range, we have to do this visually looking at the graph. So my lowest number, well, my graph goes down to -infinity. My lowest number here, we have -infinity, and we're going to go up to a static or a highest non-moving y value here at y equals 1. My y value is 1. So my range, least to greatest, left to right, is -infinity to 1 inclusive. Now, if you wrote 1 to -infinity, again, I would know what you mean, but that's not the correct way to write it because we always want the least number first, left to right. So -infinity to +1, and we stop at +1. So I hope that helps you visualize domain and range from a function a little bit better. We did 2 examples in this video, and we wrote 2 different domains and ranges, which you would be typing into the computer or writing on your homework or on your test in this form that I have boxed over here on the right of the screen. As always, please email me if you have any questions, comments, or concerns.